Welcome to the Introduction to Inequalities. This is going to be like a beginning notes page and some examples, so please label the top just like this. Okay, we're going to jump into some examples. We have a lot to learn over the next couple days, but we'll start with some examples to make sure that we remember how to solve equations and that we can apply that knowledge to what we have now, which is inequalities. The first example we'll do is 5x plus 2 is greater than 3x plus 10. Now remember that we're going to treat our inequality symbol, this greater than sign, the same way we would treat our equal sign. It's going to be the middle of our scale. And if you are solving the way I am, which means you're staying away from triangles, the only thing we're going to do to change this is we're going to take our 5x and copy it, but we're going to take our plus 2, and we see that that's a positive 2, and put it inside of a number cube. On the right side, we have 3 x's, and we have a 10. So we're going to go back to our 4 moves that we really have available to us. Either taking things off each side, adding things to each side, putting a 0 pair on one side, or taking a 0 pair off one side. And what I notice right away is that I can take 2 off of each side. I've got at least 2 on each side. So what I will have then is 5x on the left and 3x and an 8 because I took a weight of 2 off each side. Now what I think I'd like to do is I would like to get rid of these x's. So I am going to bring in 3 stars on the right, but then I also have to bring in 3 stars on the left. This set of x's and stars completely cancels, and I've got some 0 pairs on the left side. I have 5 x's, but I have 3 stars, which means that I have 3 of these x's being canceled by 3 of these stars. I will be left with 2 x's on the left and my 8 on the right, which makes my x, I'm going to go back to the top and double check, it makes my x greater than 4. I need to copy that symbol just as it was up above. Now I've got to graph this. So what I need to do is make a number line that is big enough to have about 3 to 5 hash marks on it. I've got to make sure that I have the most important number of this particular problem on there, which is number 4. So I am going to label probably like 4, and then I'll go up 2 and call this 6, and I'll go back 2 and call this 2. I'm not going to label every mark. I'm just going to kind of show what I have. And then I'm going to find the number where the correct answers begin, which is 4. Make a nice open circle on it. And I am going to point my forever arrow in the direction of numbers that are bigger than 4. The bigger direction is always to the right. This is your bigger direction. And your less than direction is always to the left. Anything to the left of 4 is less than, anything to the right is greater than. That was an easier one. Let's try one that looks a little bit different because there is a trick to solving inequalities that you haven't seen yet. All right, let's take a look at letter B, which is going to have a different twist, and it's definitely something that is new with inequalities. So letter B looks like this. And the first thing you'll notice after you copy is that you've got this symbol with another line below, and this is the greater than or equal to symbol. So that is represented a little bit differently in the number line, and we'll see that in a minute. So my first move is going to be to create my scale, and I'm using my inequality, my greater than or equal to sign, as the middle. And we're at the point now where we've got to start to do some visualizing. What I know is that if I have to take away 3 copies of 2x plus 7. Because I don't have anything here right now to take away, that means that I am going to have to bring in a 0 pair, or 3 0 pairs of 2x plus 7, and then the opposite of that, 2 star plus negative 7. I'm going to have to bring in 3 copies of each and take away the 3 copies of 2x plus 7. So I'm going to do a little shortcut, and I'm going to bring in 3 copies, but I'm going to add them all up in my head before I bring them in. For example, if I was going to bring in 3 copies of 2x, I can calculate in my head that I would have 2, 4, 6 x's. So instead of actually bringing in 3 copies like we used to do, I'm just going to say that I have 6x. And then if I'm going to bring in 3 copies of 7, I can start counting in my head that I would have 7, 14, 21. So I am going to bring in a positive 21. Now, because I need to bring in 0 pairs, I'm asked to take away something that I don't have. I brought this in so I could take it away, which means I must bring in a 0 pair at the same time. I'm also going to bring in 6 stars and a negative 21. So now I'm able to take away what I was supposed to, 3 copies of 2x plus 7, and I can go to the right side now, which doesn't ask me to do very much except translate my 19 into a number cube. So now I have to start thinking about numbers. I like to get rid of the negatives, so I am going to bring in a positive 21 on the right so I can cancel out that negative 21. And that means I also have to bring in a positive 21 on the right. What I'm able to do then is get rid of that negative 21. If I rewrite what I have left now, I've got 6 stars on the left, 2 x's, and a number cube, 40, on the right. Now, what I'd really like to get rid of is this 2x, so I am going to bring in 2 stars to cancel out those 2 x's, but then I also must bring in 2 stars on the left. Those 2 cancel, and I count up how many stars I have on the left. I have 8 stars, which is equal to 40, or I should say greater than or equal to 40. And that makes each of my stars greater than or equal to 5. Now this is the big twist. Because we were solving for star this time, what we've got to do is we've got to flip to an x. And just the same way that we flip our numbers and we say if star is greater than or equal to 5, we have to flip every single piece of this to the opposite. So we're going to have to say that x, which is the opposite of star, is less than or equal to, which is the opposite of greater than or equal to, -5, which is the opposite of 5. So the one difference between solving equations and inequalities is that you are going to have to remember to make the switch to the middle when you are bringing a star back to an x. That changes our graph over here as well, our number line. Our number line will have still about 3 or 4 or 5 hash marks on it. And we need to make sure that one of those is marked -5. I'm going to go this way and make this -7. I always have to remember when I go to the left, those numbers appear bigger. When I go to the right, they're smaller. And now, when we have this or equal to sign, we're going to fill in our circle. And we need to point to all the numbers that are less than -5. And we know from our notes above that anything less than goes to the left and anything greater than goes to the right. So as soon as I see that less than symbol, I should make my arrow point to the less than side. So the last example we're going to do has to do with switching the side of your x. You'll see what I mean when we get there. We've got 9x minus 99 is greater than or equal to 18x. So the first thing I'm going to do is I'm going to make the middle of my scale. And I've got a pretty easy translation because I've got 9 x's. I'm supposed to take away 99 that I don't have, so I can bring in my 0 pair of 99 and -99. Can take away that positive 99 that I'm supposed to. And on the right, I have 8x. 18x. What appears to me would be the easiest thing to do right now is to get rid of this 9x because that will leave 99 here. And I think I'd be able to solve it pretty easily. So what I'm going to do right away from the beginning is bring in 9 stars to each side. That would leave me on the left with -99. And on the right, I have to do a little bit of thinking. If I had 18 x's, but 9 of them are canceled out by stars, that would leave me with 9x left over, which means that in this case, I would have my symbol looking like this. I would have -11 is equal to x, or excuse me, -11 is greater than or equal to x. Here's where things get a little different. It is harder to read for a lot of people what this looks like on the number line. So a lot of times it's easier to turn it around and have the x come first. If you turn things around, if you decide to write this with x first, you have to notice that at this point, the pointy part of your inequality symbol is by the x. So if you're going to switch things around and choose to write it differently, so you can see whether x is greater than or less than, you've got to keep that pointy part, that less than part of the arrow, close to x before you go turn things around. So you're allowed to change x and -11, but you do have to make sure that you change the direction of the arrow so that if the smaller part, the less than part, was by the x up here, the less than part remains by the x here. Now you can go ahead and make a number line and graph that on a number line and start your practicing.